Okay, let's talk about the basic operations of radicals, square roots, cube roots, or nth roots today. Okay, so first is addition and subtractions. Okay, addition and subtractions. So addition and subtractions of square roots. Okay, so we have to combine like radicals. Okay, like radicals. So what means like radicals? Exactly same radical part. Okay, so this means same radical part. Okay, so 2 square root of 3 and 5 square root of 3. They are like radicals because they have same radical part, square root of 3. Okay, square root of 3. So we don't care the number before the radical part, the integer whole number part. We only look at the numbers, the expressions under the radical sign. They have to be the same. If they're the same, these two terms, the whole thing, means like radicals. Okay, you may even have letters inside, right? So let's say 2 radical 3xy and 5 radicals 3xy. So they are also like radicals. Okay, you have exactly the same radical part. Okay, you have a radical part. You may add 2x here, 5y here, that doesn't matter. Okay, that doesn't matter. We only look at the radical part. Okay, so now if you have two like radicals, okay, so this is 8 radical 13, this is 9 radical 13. So when you add them, this addition sign really means you keep the common radical, okay? So square root of 13, you will keep that part. Keep the common radical part, and then add the integer part, the whole number part, okay? So here we have 8 and 9. So we have 8 plus 9, 17. Okay, it's like you have 8 apples plus 9 apples. So you keep, okay, how many? You have 17 apples. Okay, so here we use the same idea, okay? We keep the radical parts. Radical parts are the apples. Okay, so we keep radical 13 and then add 8 and 9. Okay, so this means we have 8 radical 13. And we have 9 more radical 13. So in total, we have 17 radical 13. Okay, subtraction. Okay, subtraction, still, we keep the radical part. Okay, so they have to be exactly the same, and then we keep it. So now, there's no number before this radical. So that means we have 1, right? We have 1 radical 17x. So subtraction means 1 minus 20. Okay, so here is the subtraction. Add or subtract is the part before radicals. Okay, before radicals. So 1 minus 20 is negative 19. Okay, negative 19. So now there is a problem. So suppose we have 8 radical 2 plus 9 radical 3. They are not like radicals. They are different. So if they are different, you cannot combine radicals. This is a simplified final result. You cannot put them together. Okay, it's like you have 8 apples, 9 bananas. It doesn't matter how you look at it, how you count it, it's still 8 apples, 9 bananas. You cannot put them together. Okay, cannot put them together. So for addition and subtraction is only for like radicals. One more example, harder examples. Okay, so now let's look at square root of 108 minus square root of 27. Okay, so in the beginning, they looks like different. They're not the same number, right? Okay, yeah. So you cannot have addition or subtraction. Okay, so step 1, we have to simplify these two parts, change them to same radicals, like radicals. Okay, so step 1. Change to like radicals. Okay, so now let's simplify radical 108. Okay, so what's radical 108? If you know that, this is 3 times 36, right? Square root of 3. This is square root of 3 times square root of 36. Square root of 36 is 6, so this is 6 radical 3. Okay, 6 radical 3. So this is the first one. The second one is 27, so we need a square, right? So it's 3 times 9. That's 27. So this is radical 3 times radical 9. So this is 3 radical 3. Okay, 3 radical 3. So square root cancels squares, right? So here is square root of 6 squares. Square root and the square canceled. We got number 6 here. Okay, so this is square root of 3 squared. Square root and square canceled. So you got number 3 here. Okay, number 3. So after you simplify these two radicals, so this one you got 6 radicals 3. The second one you got 3 radicals 3. Now they're like radicals. Okay, so step 2, add or subtract. Add or subtract. So we keep the common radical part, keep this. Okay, so we got radical 3. Subtraction is for 6 and 3. So 6 minus 3, so we got 3 radical 3. Okay, so for harder questions, okay, you have to change different radicals, simplify them to get a common radical part. Okay, so when you have like radicals, you can add or subtract. Okay, add or subtract. Okay, yeah. So now some students don't know, okay, how did I find this 3 and 36? It's very hard. Okay, it's very hard to guess what's the biggest square. 36 for 108. So now let me show you another way. Okay, let me show you another way. Same question, second solution. Okay, yeah. So now let's factor this 108. Okay, 108, even number divided by 2. What do you got? 54. 54 divided by 2, you got 27. 27 divided by 3, you got 9. And then split 9, you got 3 and 3. Okay, so this is 108. So 108 is 2 squared times 3 cubed. Okay, so we just factor it, use prime numbers. Okay, so what are the prime numbers? Primes 2, 3, 5, 7, and some other numbers. Okay, yeah. So 27, we do the same thing. Prime factorization, right? 27 divided by 3, 9. 9 divided by 3, 3. Okay, so 27, we got 3 cubed. Okay, 3 cubed. So first, we write down the prime factorization. 2 squared is 3 cubed for 108, and then 3 cubed for 27. Okay, 27. So now we are looking for squares, okay, in this prime factorization, because square root and square cancel each other, right? Cancel each other. So now I'm going to rewrite it. Okay, I will write down some squares. So 2 squared is a square, and then I will split this 3 cubed to 3 squared and a 3. Okay, so I do the same thing here. This 3 cubed, I write down 3 squared and a 3. Okay, and a 3. So now we have some squares in the square root sign, radical sign, right? Radical sign. So let's use multiplication rule, rewrite it. Square root of a times b is square root of a times square root of b, right? Yeah. So now square root cancel with the square. Square root cancel with the second power. Square root cancel with the second power. So we have 2 times 3 radical 3 minus 3 radical 3. So we got the same result, 6 radical 3 minus 3 radical 3. And the answer is 6 minus 3, keep radical 3, which is 3 radical 3. Okay, 3 radical 3. So for big numbers, okay, for big numbers, if you know this is 3 times 36, if you can find this perfect square, okay, you have a shorter calculation, shorter solution. If you can't find it, use these prime numbers, keep factoring it. Then you can find some powers, and then rewrite these powers, figure out the squares, and then move out the squares, cancel the squares with the square root sign. Okay, square root sign. So this is the second solution. Okay, second solution. So now let's look at another example. One more example. Okay, so it's 3 radical 50 plus 4 radical 8. So again, we need squares under the radical sign, right? 25 is a square, so 25 times 2 is 50. 8 is 4 times 2, right? 4 times 2. So now we rewrite it using product rule, right? Product rule. Okay, so for this step, we use this idea. AB is radical A times radical B, if they are all real numbers, okay, if they are all real numbers. So now this is 5, this is 2, right? So we got 3 times 5 radical 2 plus 2 times 2 radical 2. So this is 15 radical 2 plus 4 radical 2, which is 15 plus 4. This is the addition part, okay? And then we keep the common radical. So this is 19 radical 2, okay? 19 radical 2. So if you look at our two recent examples, the addition part is very easy, okay, for radicals. So the hard part is you change different radicals, simplify different radicals to get like radicals, okay, to get radicals. So this is only numbers, right? So now let's have an example which have some letters, right? So 2t cubed square root of t cubed plus 3 square root of 4t, okay, 4t. So again, we want to factor out or simplify squares under the radical sign, okay? So now split again. So this is square root of t squared times square root of t plus square root of 4 times square root of t. So these two parts can be simplified because they are squares, right? Because they are squares. Square root of squares. So this is 2t radical t plus 3 times 2 radical t. So this is 2t radical t plus 6 radical t, which is 2t plus 6 radical t. Okay, and that's the final answer. Cannot simplify anymore. Okay, cannot simplify anymore. And we use the same idea for nth root. Okay, so let's look at example for cube root. Okay, for cube root. So 3 cube root of 3x plus cube root of 2x minus 2 cube root of 16x. Okay, 16x. So now first, you cannot simplify these two cube roots, and they are different. You cannot combine them. Okay, cannot combine them. Okay, so the only part we can work on is this cube root. We can change this one to get some like radicals. Okay, so now let's copy the cube roots. So now let's copy the first two terms. So now we need cube root. Cube root and the third power, they cancel each other. So we need a cube here, right? So what is 8? 8 is 2 cubed. Okay, 8 is 2 cubed. So cube root of 8 is 2. So we can simplify this number 8 under the cube root. Okay, cube root. Now let's rewrite it. Cube root of 2x minus 2 times cube root of 8 times cube root of 2x. Okay, cube root of 2x. So this is the part that we want. We can simplify. This is 3 cube root of 3x plus cube root of 2x minus 2 times 2 cube root of 2x. So now we get like radicals, right? They are exactly the same. Okay, they're exactly the same. So the first part has to be fixed. And then we have 1 minus 4 here, right? 1 minus 4 cube root of 2x. So the answer will be 3 cube root of 3x minus 3 cube root of 2x. That's the final answer. You cannot combine them because they're different. They're not the same terms and numbers under the cube root. Okay, cube root. So that's addition and subtraction. Okay, yeah. So now let's look at multiplication and division. Okay, multiplication and division. So the easier case, we just use these formulas. Radical A times radical B is radical AB. And radical A divided by radical B is radical A over B. Right, so let's look at easier case. So square root of 2 times square root of 3. So this is square root of 2 times 3, which is square root of 6. Okay, yeah. And then 2 square root of 2 times square root of 30 divided by square root of 5. So we use multiplication formula on top. And then use division formula for the numerator and denominator now. Okay, so 2 times 30, 60 divided by 5, 12. So we got radical 12, and then again, radical 12 can be simplified. So this is not the final answer, okay? So this is radical 4 times radical 3, so this is 2 radical 3. So you have to simplify all the radicals, okay, for the answers, okay, for the answers. So this is the easier case for multiplication and division, okay? Multiplication and division. So harder case, we may have some integers or some numbers outside the radicals, okay, outside the radicals. Let's look at example 3. So we have 4 radical 2 times 5 radical 3. Okay, so now for this case, we use radicals multiply radicals by radicals, and numbers multiply by numbers, integer, integer. So 4 times 5 outside, inside we have 2 and 3. We'll look at these two parts separately. Okay, outside times outside, inside times inside. So this is 20 radical 6. Okay, 20 radical 6. So this is the multiplication and the division part. Okay, division part. So the harder case, we need distribution, right? We need distribution. So let's look at example 4. So suppose you have 3 radical 2 times 2 radical 3 plus 5 radical 2. Okay, so this is a distribution property. Okay, distribution property. So we have 3 radical 2 times 2 radical 3 for the first product plus 3 radical 2 times the second term, 5 radical 2. Okay, 5 radical 2. So inside times inside, outside times outside. So 3 times 2 outside. The radical sign, 2 and 3 inside. For the second product, 3 and 5 outside, and then 2 and 2 inside. So this is 6 radical 6 plus 15 times, so square root of 2 squared. So this is number 2. Okay, number 2. So we can simplify that part. We didn't get the radicals, we get a good number, right? So the answer is 6 radical 6 plus 15 times 2 is 30. And that's the final answer. You cannot combine them because they're not like radicals. Okay, they're not like radicals. So one more example. Okay, one more example about distribution case. So let's see, we have radical 5 plus radical 3 times radical 5 minus radical 3. Okay, minus radical 3. Okay, yeah, so now if you know FOIL method, this is FOIL, FOIL, right? First times first, and then outer term times outer term, inner product, and then last term times last term. Okay, so FOIL. Okay, FOIL. So first times first, radical 5 times radical 5. Between them, we use plus, right? Plus outer times outer, radical 5 times negative radical 3. Inner product, radical 3 times radical 5. Outer product, radical 3 times negative radical 3. Okay, then we use the product rule. Square root of a times square root of b is square root of a times b. This is square root of 15 minus, this is 5. So square root of 25, so minus square root of 15 plus square root of 15 and minus square root of 9. Okay, square root of 9. So now you look at the middle two. They're the same and they're cancelled, right? They're cancelled. So we have 5 minus 3. This is 5. This is 3. So this is 2. The answer is 2. Okay, so we have a bad radical and we have another bad radical, but we got a very good answer. Okay, we got a very good answer. Okay, so now let's look at one more example. 1 plus radical 2 squared. So this is 1 plus radical 2 times 1 plus radical 2. FOIL again, right? First, 1 times 1. Outer product, 1 times radical 2. Inner product, radical 2 times 1. And then last times last, radical 2 times radical 2. Okay? So this is F O I and L. Okay, between F, O, I, L is addition. Okay, is addition. Then we have 1 plus radical 2 plus radical 2 plus 2. Okay, so we can put these two together. They are integers 3. And here we have 1 radical 2, 1 radical 2. So when you add them, it's 1 plus 1 radical 2. Keep the common part, common radical part. So the answer is 3 plus 2 radical 2. Okay, so this is the multiplication distribution for radicals. Okay, for radicals. So now let's look at rationalized denominators. So there are two cases about rationalized denominators. Okay, yeah. So first case, there's only one term in the denominator. Okay, so let's see, 2 over radical 5. Okay, over radical 5. So our goal is change this number to a rational number. So change radical 5 to 5. Okay, this is our goal. So how to change radical 5 to 5? So you pair radical 5 with another radical 5. Okay, square root of 5 squared is 5. Okay, yeah. So now numerator and denominator, you need the same radical 5. Okay, you have to keep the value. Okay, keep the value, keep the ratio. So bottom is radical 5 times radical 5. Numerator is 2 radical 5. 2 times radical 5. So the answer is 2 radical 5 over 5 in the denominator. Okay, so this is the easier case. Just pair the denominator with exactly the same expression. Okay, same expression. So let's look at another example, right? Another example. So if we have 2 radical x divided by 3 radical y. Okay, 3 radical y. So rationalized denominator means no radical sign. Okay, no radical sign. So there is a square root of y in the denominator, so we need square root of y over square root of y. Numerator and denominator, we use the same radical y. Okay, same radical y to keep the ratio. Okay, to keep the value of the fraction. So denominator, this gives us letter y, right? So we have 3y here. Numerator, product rule again, so we have xy in the radical sign. Okay, in the radical sign. So this is the answer of rationalized denominator, easier case. There's only one term in the denominator. So some questions, there are 2 terms in the denominator. Then we need conjugated radicals. Okay, so this is conjugated radicals. Okay, so square root of either 2 terms, radical A and radical B. Okay, so if you put plus sign for one and minus sign for the other one, these two are called conjugated radicals. Okay, conjugated radicals. So what's the good property of conjugated radicals? Radical A plus radical B times radical A minus radical B is a good expression without radical sign, A minus B. Okay, A minus B. So let's check it. Okay, for your method, right? For your method, radical A plus radical B times radical A minus radical B. Okay, yeah, the only difference between them is one is plus, the other is minus. Okay, so F product radical A times radical A. Okay, outer product radical A times negative radical B. Inner product radical B times radical A. And last product radical B times negative radical B. Okay, radical B. So this is A because it's A squared, right? This is minus radical AB, the second term. This is radical AB, the third term, and then minus radical B squared, so it's B. Okay, so the middle two canceled, plus minus, radical AB canceled, so it's A minus B. Okay, A minus B. So conjugated radical is the second method to rationalize denominator. Okay, rationalize denominator. So let's look at an easy example. So 1 divided by radical 2 plus radical 3. Okay, so we want to rationalize denominator. Okay, so what you should do, you pair this denominator with its conjugate. So how can you change it to conjugate? Use minus. Okay, you're given plus, you use minus. You're given minus, you use plus. So both numerator and denominator times radical 2 minus radical 3. Okay, radical 3. So now for the numerator, anything times 1 is the same thing, so you got radical 2 minus radical 3. For denominator, is a product of conjugated radicals, so it's a minus b, if you remember, right? Radical a plus radical b. Again, the formula, radical a minus radical b is a minus b. So this is the formula. So we got 2 minus 3 here. Okay, so it's radical 2 minus radical 3 over -1, so which is radical 3 minus radical 2. Okay, radical 2. So this is a easy question. Okay, this is an easy question. Rationalize denominator. Okay, so now let's suppose you are given the minus sign, right? Radical 2 minus radical 3. A new example. Okay, so how to change this denominator to a rational expression? So we need its conjugate, so multiplied by the plus. So numerator, 1 times radical 2 plus radical 3, so it's radical 2 plus radical 3. Denominator is a minus b, so it's 2 minus 3 again, right? So this is radical 2 plus radical 3 minus 1 in the denominator, so it's negative radical 2 negative radical 3. Okay, negative radical 3. Now let's look at a harder example. Let's look at this example. Okay, let's look at this example. So this is the denominator, 4 plus radical 5. Okay, 4 plus radical 5. Okay, so now you see it's not radical a minus radical b, right? So we have 4 plus radical 5. So what's 4 plus radical 5? So it's radical 16 minus radical 5 plus radical 5. Okay, so what's its conjugate? Conjugated radical is minus sign, right? So it's 4 minus radical 5, or you can write it down as 16 minus radical 5. Okay, 16 minus radical 5. So the only difference is plus change to minus, minus change to plus. Okay, yeah, so now let me repeat the calculation here, right? We want to change the denominator to a rational number, rational expression. So 8, 4 plus radical 5. So multiplied by its conjugate, so it's 4 minus radical 5, 4 minus radical 5. Okay, yeah. So the bottom, if you change 4 to radical 16, right? So this is radical 16 plus radical 5, radical 16 minus radical 5. The top, 8 times 4 minus radical 5. So denominator is easier. Denominator is a minus b. So here we use this formula again, right? Radical a plus radical b times radical a minus radical b is a minus b. Okay, is a minus b. So we are using the same formula. Okay, so denominator is 16 minus 5. Numerator, distribution rule. 8 times 4 is 32. 8 times radical 5, negative, so it's negative 8 radical 5. So the answer is 32 minus 8 radical 5 over 11. Okay, over 11. Just use its conjugate. That's our second method to get rational expressions, to get a better denominator. Okay, to get a better denominator. Okay, so now let's look at some questions from the web work. So they have bigger numbers. Okay, they have bigger numbers. So let's look at 1 over, so let's say 3 over radical 5 minus 3 radical 3. Okay, 3 radical 3. Okay, yeah. So the conjugation is easy, right? The conjugation is easy. So we multiply it by the plus sign, plus. So it's 3 radical 5 plus 3 radical 3. Okay, 3 radical 3. So now the numerator is 3 radical 5 plus 3 radical 3 multiplied by 1, so you got the same thing. Okay, you got the same thing. So for denominator, you try to follow your method. So basically, what will stay here is this thing squared minus the second term squared. Okay, second term squared. So let's check it, right? Let's check it. So 3 radical 5 minus 3 radical 3, 3 radical 5 plus 3 radical 3. So first, so this is the first term squared. Okay, and then this product is plus 3 radical 5 times 3 radical 3. Inner product minus 3 radical 3 times 3 radical 5. And the outer product minus 3 radical 3 times 3 radical 3. Okay, so the middle two cancelled. So what the result is the first term squared minus the second term squared. Okay, second term squared. So if it's radical A minus radical B times radical A plus radical B, it's easier. It's A minus B. Okay, it's A minus B. Otherwise, it's the first term squared minus the second term squared. Okay, yeah. So now let's write down a more general formula. This was a formula in the Math 5. Okay, A plus B times A minus B for any AB. They don't have to be radicals. Okay, it's A squared minus B squared. So for harder case, you can use this formula. Okay, you can use this formula. So it's the first term squared minus the second term squared. So it's 3 radical 5 squared, 3 radical 3 squared. Okay, so what is 3 radical 5 squared? 3 radical 5 times 3 radical 5. So we got 9 here times 5. Radical 5 times radical 5 minus 3 radical 3 times 3 radical 3. So this is another 9 and then another 3. Okay, yeah, so this is the denominator. Okay, denominator. Numerator is the same, 3 radical 5 plus 3 radical 3. Okay, so denominator is 9 times 2, 45 minus 18, 27 is 18. Okay, and then the numerator is 3 radical 5 plus 3 radical 3. Okay, so now we have two formulas. You either use this formula or you use radical A plus radical B times radical A minus radical B is A minus B for easier question. Okay, this is for easier question. This is for harder question. Okay, this is for harder question. And some numbers are very big. Okay, some numbers are very big in the web work. So for example, we have 363 divided by 5. Okay, rationalize this denominator. Okay, rationalize this denominator. So now we rewrite it. So it's the square root of numerator times square root of denominator. So rationalize denominator, we need radical 5 on top, radical 5 on bottom. So now denominator is okay. Denominator is 5. What about numerator? Okay, what about numerator? Do not multiply them. Okay, so we have radicals 363 times radical 5. Don't multiply them. You need to factor 363 to get a better simplified radicals and then multiply that. Okay, so 363 divided by 3 is 1 to 1. So divided by 11 is 11 times 11. So it's 11 squared. Okay, 11 squared. So radical 663 is 3 times 11 squared times radical 5. Right, so now this is square root 3 times 5 times 11 squared divided by 5. Okay, so now 11, this is square root of 3 times 5 square root of 11 squared over 5. Square root and second power for number 11 canceled, right? So we have 11 over 5. That's the good part times the bad part. Radical 3 times radical 5, radical 15. Okay, radical 15. So the numbers are bigger for some questions in the web work. And for big numbers, use prime numbers to factor that, right? Again, prime numbers 2, 3, 5, 7, 11, 13, 17, 19, and continue. Okay? Okay, so that's it. That's the second lecture about radicals.